All right, today we're going to be talking about simplifying radicals. So we're going to be practicing simplifying radicals when the powers or the roots are greater than just the square root. And we're also going to be rationalizing the denominator. So let's take these notes together. Here's how we know if something is in simplest form. So this is a test when you feel like you have completed simplest form, check this to make sure that it's true. All right, if you will copy these down, here's how you know if your radical is simplified. So first off, all possible nth factors have been removed from the radical. That means that under the radical, everything is simplified, right? And then no radical contains a fraction. So you shouldn't have a fraction under your radical. And then no denominator of a fraction contains a radical. So let's just really talk about first how to simplify when we have something that's greater than a square root. So here's an example. All right. If we have the square root of 48, since it's the square root, right, it's an understood 2 there, we're looking for perfect squares. Well, I know that 16 is a perfect square that goes into 48. So this is the same as the square root of 16 times the square root of 3. Well, the square root of 16 is 4, and there's not a square root of 3, so we're done. You can also think about it like this. You can break it down into your prime factorization. So you can also use prime factorization. So if we took the square root of 48 and broke it down into all of my prime factors, move that up so you can see it a little bit better. This would be the same as 2 times 2 times 2 times 2 times 3, right? And since we're looking for square root, we're looking for groups of 2. So based on this number here, the index, right? So groups of 2 have 2 2's. So we have a group of 2 here. So once you find 2, you take 1 out of the radical. I found another group of 2, so I can take that out of the radical. And this 3 is by himself. He does not have a group, so he stays in. So our answer there is 4 root 3. Same answer, right? Just 2 different techniques. This prime factorization technique helps and will help when our index is higher than 2 or even higher than 3. When we get more than cubed root, it kind of helps to know what that prime factorization is. So let's try one if my index is higher than 2. So let's say that we have the cubed root of 40. Let's break this apart into our prime factorization. This is 4 times 10, 2 times 2, and 2 times 5. So my prime factorization of 40 is 2 times 2 times 2 times 5. So I'm looking for the cubed root, right? So instead of here looking for groups of 2, I'm going to be looking for a group of 3, right? Based on my index. Your index is this number. So I have a group here. So once you find one group, you can take one of the 2's out. 5 doesn't have a group, so it stays inside. So your answer there is 2 root 5. This also works with variables. So let's look at an example with a variable. Number these. So let's say, make it a little bit difficult, right? So let's say that we have the cubed root of 54x cubed y to the 5th, okay? So let's break apart our 54. We know that it is 6 and 9. So we have 2 and 3 and 3 and 3. So our prime factorization here with the variables is 2 times 3 times 3 times 3. We have 3 x's, it gets kind of long, and 5 y's. So I'm looking for groups of 3, right? So I have a group of 3 here, a group of 3 here, and a group of 3 here. So that tells me what I can take out. I can take out a 3, an x, and a y. So I can take out a 3, an x, and a y. And what I did not circle is what gets left inside. So a 2 gets left inside, no x's, I took them all out, and 2 y's get left inside, all right? So that's your answer for that one. All right, so that simplest form, meaning all possible nth factors have been removed from the radical. Let's look at rationalizing the denominator. So when you have a radical in the denominator, you have to rationalize. Rationalize the denominator. Okay. All right. So you are probably pretty good at rationalizing the denominator with the square root, but what about a cubed root? So let's just refresh for square root. Here's the square root of 3/5, right? So remember it said in one of our simplest form, it said you can tell if no radical contains a fraction. Well, this radical contains a fraction, so it's not in simplest form. I can rewrite this as the square root of 3 and this over the square root of 5. Now, I want to rationalize because I can't have a radical in the denominator. So I need to change the number without actually changing it. And how do you do that? What can I multiply by a number to change it the way it looks, but not what it is? So this is called your identity, your property of identity, right? So you can multiply anything by 1, and it doesn't really change. Doesn't change its identity. So I want to multiply this fraction by a form of 1 that doesn't actually change what it is, just changes what it looks like. And I know that I can multiply any number over itself, and that's the same as 1. So square root of 5 divided by square root of 5 is 1, and it would help me get rid of this fraction in the denominator. So I have the square root of 25 on the bottom, and the square root of 15 on the top, which would simplify to the square root of 15 over 5. So that is simplest form, right? I didn't change the actual number because it's still square root of 3 over 5. They're still the same thing. I just changed what it looked like by multiplying it by a form of 1. So let's try an example with a cubed root. So let's do this. We have the 4th root, or 4 divided by the cubed root of 3. So I'm going to rationalize this, except remember here, I'm looking for a group of 3, right? So I need 3 3's in order to take it out of the radical. So think to yourself, how many more 3's do I need to make a group of 3? I need 2 more 3's. 2 more 3's to make it a group of 3. So on the top, we would have the 4th root, or 4 times the cubed root of 9 divided by the cubed root of 27. Well, the cubed root of 27 is 3 times 3 times 3. So that 3 comes out of the radical. Oops, let's adjust that. There we go. So this is your answer. If you put this in the calculator, you would get the same irrational number or decimal. So they're the same, these are the same, except this one is completely simplified. We can do that with other numbers too. So let's try it with a 9 in the bottom. So if we have the 4th root, or 4 divided by the cubed root of 9, Notice that 9 is the same as 3 times 3, right? So how many more 3's do I need? I only need one more 3. So we're going to multiply it by the cubed root of 3. Oops, divided by the cubed root of 3. So on the top, we have 4 times the cubed root of 3 divided by 3. So that's a little bit different because I already started out with 2 3's and I just needed one more to make it rational. Okay. So once you complete these exercise problems, please bring me your notes and show me your exercise problems, and then you can start your practice work. Right here are your you try. There are 5 of them. Go ahead and do these 5 and then bring me your answers when you get them. You can work with a partner on this if you'd like to.